Alright, hello, this is Module 3, Investigation 3, using and interpreting function notation. So, number 3, I supposed to do the A, B, C, I, J, L, but I think I'm going to do every problems. Alright, so these problems are torus and hairs are the completing the race. Okay, so it's fun problem. Alright, torus and hare are competing in a race around 400-meter track. The Aragon hare decide to let the torus have a 225-meter head start. When the start gun is fired, the hare begins running at a constant speed of 5.5 meters per second. And the torus begins crawling at a constant speed of 2.0 meters per second. Let t represent the number of the seconds since the start gun was fired. We are interested in determining who won the race. So A, illustrate the situation with a diagram, mark up the length of the race, note the approximate the position of the torus from the starting line and the position of the hare, illustrating the varying quantity with the vectors, etc. Okay, so first of all, this is the route, which is from here to here, is 400 meters. And then the hare starting from here, and then the hare let the torus crawling 225 meters, and then torus is right here. Okay, so torus has a less meter to go, right? Hare gonna run the all 400 meter, but torus gonna actually the remaining whatever remaining the 400 minus 225, and the hare is actually the running to the 5.5 t, right? So every second he goes a 5.5 meter, and torus goes to the 2.0 per second, so 2t. So which means the remaining what if the torus went up to here, which means the torus need to go from here to up to here, right? It's gonna be the remaining length is actually the from here to here is 175 meter, right? Okay, so the finish line to the where the torus is always 175, then minus 2t. But for the hare, right, he need to go to all the way to the end from the starting line, so he go to the 400 minus 5.5t. Okay, but what are we looking for is, okay, but that's the, actually we can think about this way, okay? And then let's do the B. Define a function g represent the torus distance from the finish line in terms of the number of the second t since the start gun was fired. So torus, we use a g function of the t. So torus, when you take a look, so the distance from the finish line, right? So this is, so from here to here, right? So we are talking about this. So which means torus is always 175 minus 2t. And then C, define the h function represent the hare's distance from the finish line in terms of the number of the seconds since the start gun was fired. So h function for hare, but he need to go 400 meter, but each second 5.5 meters reduced, right? So 5.5 t. Okay, so evaluate the g of 40, which is we use the g functions, which is the torus distance from the finish line to the torus. So 175 minus 2 times 40 give us a 95 meter. Okay, and then for the what if, how many seconds it takes when the distance between the torus to the finish line is 80, right? So I put the 175 minus 2t equal to 80. And then so for t. So I subtracting 175 both sides. And then negative 2t is okay, so 80 subtracting 175. And then I got negative 95. Yeah, this is one negative. I don't know why, but it looks like a 2 negative in the front. Negative 2t, right? And then you divide by negative 2 both sides. And then t is equal to it'll be the 47.5. Okay, meter over seconds. So you'll take the 47.5 seconds to go for the make the distance between towards the finish line is at 80 meter. And so for ht equal to 0, which is the hairs actually to complete the race, right? So which means I put the 0 equal to for the h of t, and then it's gonna be 40 minus 5.5t, and then I'm gonna solve for t, so which is add 5.5 both sides. And then I got 5.5t equal to 400 and divide by 5.5 both sides. And then the second becomes 72.727 seconds. Alright, G. Construct the graph G and H on the axis, okay? So what I do is I'm going to start with the G function. So G function, which is starting from here, right? So I'm doing the G right now, okay? So G function graph is when the T and G of T, right? So 0 second, the torus was 75 meter away from the finish line. So 75 is about here. Okay, and then when he finished the line, which is you just set up the torus finish the line, which is set this equal to 0 and 175 minus 2t, and then the solve for t. So for t is 87.5 seconds. So when the finish the race was 87.5, so about here. Then I'm gonna connect these 2 points as a linear because he has a constant speed. Okay, so we got this. All right, for so this is the G functions graph, and for the hairs, okay, let me use another color for the hairs. So hairs, let me use the green. So hairs actually at the beginning of the 0 second, T and H of T, right? So 0 second, he was 400 meters away, right? So 400 is about here. And then at the end, when he finished the race, which was, we already had it here, right? In the F, okay? So it takes a 72.727 seconds, okay? So 72 is about here, okay? And then I'm gonna make the straight line. So, okay, so let me make the straight line from here to here. So, alright, here we go. Oh, sorry. So, yeah, that's the graph. So this is the H functions. Alrighty, now we did the G, right? And then evaluate the H of 20 minus G of 20. So they're talking about 20 seconds, okay? So 20 means a second, right? Time. So how much distance in here? So from here to here. So we're asking for how much distance, the difference of the distance between the torus and hairs. So what I do is plug it in. Plug in 20 into the H function, which is H function as 400 minus 5.5 times t, which is 20, which give us 290. And then the G of 20, which is 175 minus 2 times 20 give us 135. So subtract the h of 20 to g of 20, which is 290 subtract 135, and then I got 155. So this is the distance between the torus at the 22nd. And then I, which is, I was not complete the sentence here, so I want to read it for you. Define the function f, where the f of t is h of t minus a g of t. And the graph these functions on the axis in part G. What does the function f represent? How does the graph of f relate to the graph of the h and g? So h function was 400, subtract 5.5t, subtracting of g function, which was 175 minus 2t, and then I got 225 minus 3.5t. Okay, so this we call the f functions. So let's put the f functions on the plane. So let me use the blue. Okay, so starting from the 225. Okay, and then the speed between these two guys are the 3.5 meter per second to be reduced, right? Every second, right? So, but if I set up the 0 for the h of t, so for t, 3.5t is 225, and t equal to, so 225 divided by 3.5, that becomes about 64.286 seconds. So it will take us 64, so about here. So this is a graph of this is between the torus and hairs. Okay, so the J, what is the slope of the graph of f function, which is going to be negative 3.5, isn't it? Oh, sorry. That is the total slat over the hair decreases at the constant rate of the 3.5 meter per second. So that's what it is, okay? So what does the distance means here, right? That means the torus lead over the hair decreases at a constant rate of 3.5 meters per second. And then K. Solve the g of t equal to h of t, which means when do they meet, right? So I set the g of t is the same as 175 minus 2t. H of t is the same as 400 minus 5.5t. And then so for t, so I'm gonna adding the 5.5t both sides and subtracting the 175 both sides, okay? So we can cancel this and cancel that. And then I got 3.5, t equal to 225. So divide by 3.5 both sides. And then t is equal to 64.286, which is right here. Yeah, we already put that in here, right? Right here. So those are the places, which is about here, right? So that's the place. Okay, so who won? So as you notice in here, the hairs takes about hairs takes about 87.5 seconds. And then torus takes 72.727 for the completing the race. So as you notice, the torus won, isn't it? This time. Oh, the hair, right? Sorry. The hair won the race. Okay? Because the hare finished the race in 72.727 seconds, and the tortoise finishes the race in 87.5 seconds. Okay, so hare won. But the story that you might read earlier should be the tortoise was be one because hare was kind of arrogant, right? Okay, alrighty, that's for this investigation. Thank you for listening.